So let's make a start on this. I'm going to just start the MasterSeries, and we're going to just go through some typical questions that we have. And one of the ones that I get frequently, or I should want to say the guys up in tech support get frequently, is to do with customization and what we can do. We can stipulate, for example, what is going to be the default directory what we want to work in, and we can then save that as a file. We can also set up how we want items displayed, whether we want to use DirectX graphics. We can set up which design codes if we've got multiple codes. We can set up what steel sections to use, and I'm going to come back to that in a moment, and even what color schemes to use. And once you've all that set up, you can save it as the default master file or cus file, or you can give it a different name. So if you had 2 or 3 people sharing the one computer, you can create different schemes for different directories, for different color schemes, for different whatever you want. The area I wanted to concentrate in here was the steel sections. We can tell it which grades we want to use. So for example, I can say I'm in the UK, I want to get rid of all these overseas grades, and I want the default grade to be S275. And I can then turn around and say, well, I don't want any IPEs, and I don't want any IPNs, and I don't want the cold rolled sections, and I'm just going to keep my L's and not my ANGs, and I'm going to get rid of channels, so I'm going to use parallel flange channels. So I can select which groups of section sizes I want to get rid of. In my case, because I'll be moving through a whole lot of different files today, I'm actually going to leave them all in, and I don't want to just get that error where suddenly a section is not included in the list. And then for each group, we can go and say, well, let's look at our UBs, and you could say, well, I never want to see these wee 102 wide 300 deep sections. They're far too skinny and unstable. I'm going to get rid of those. And likewise, I could get rid of the 356 by 102s, and I can then remove again sections that I either don't want to specify, or if I'm working in an overseas market, possibly they're not sections that are rolled, and away you go. So 2 things we can customize, 3 things we can customize: the grades, the groups, and what's displayed in each group. The other thing we can do is we can add our own sections to the lists. Now, I don't want to go through all the different processes to do that, other than I will actually direct you to a little document. I just log in here into our website. We have our technical notes. If I go to technical notes and scroll on down to general, no, sorry, not general, it's frames. So there we are, master frame. We will see that there is a very good document on creating an open library section, and it will walk you through all the different steps, 9 steps to creating it. And it's pretty straightforward, but it's worthwhile just having that in front of you while you do that. So that is very, very useful for creating your sections that you want to use over and over again. You wouldn't use this open library if you're doing a one-off plate girder. We can do those inside the program. So back to MasterFrame, and the next thing I want to look at in here is something called changing the drive. Now, by default, our library is stored in the program files. On a 64-bit, it's the x86, and then MasterSeries Open Library. You can store that on a drive that's used by all your different users, say on a server, and thus you can have everybody using the one list of visible sections and grades and everything, so that they're all using identical information all the time. and you do that just by changing the drive, selecting where you want to store it, and away you go. So I'll just stick to my default, and I can back out of this. Exit using the current sections. Yes, we'll stick with the S275 as a change, nothing else. So the next topic I want to cover is Dxf. So what I want to do now is I want to go into AutoCAD, and we'll have AutoCAD and look at a typical Dxf frame. Now what I would stress is today that this isn't a selling webinar. It is primarily for existing users to get more familiar with some of the tricks and some of the shortcuts. So if I come into AutoCAD, once it's finished its work, and open up either my drawing, and this is a typical wireframe. If you're going to do a Dxf file import it into MasterFrame, you need to create a wireframe of all the center lines. Now obviously this is in 3D. It's also in millimeter units, so that is, say, 6,000 millimeters. You'll also notice that we have drawn each of the members distinct along its length and stopped it where it would expect to stop at the node points. Now I've created one or two little bugs in this because we're going to come through and we're going to look at these bugs as well. So if you look here, you've got a member running right across from here over to here, and likewise you've got this member, so there's no node at this point. We also have different colors, and those different colors represent different layers. So for example, if I take those, I could then change the layer color if I wanted to. But we have all these different layers, and I could actually turn off the green ones. Yep, turn that off, and we now no longer see our columns. And I put those back on just to prove that they were in different layers. So we have our sections in different layers. The names don't really mean much. They are useful to you, and we'll see what happens to them, but they're not that important as long as they have different layers. So I've already saved it, so I don't need to save it again. It would just be saved as an ordinary Dxf file. Into MasterFrame, MasterFrame, import a Dxf file. Now the Dxf is available to everybody. If you want to import StruCAD, XSteel, or even Revit files, you need to have our MasterCAD program. But for MasterFrame users, the Dxf import and export is available. So I'm going to go in to Demo Original and then into Workshop, and I have my MasterFrame layered drawing. I'm going to open it, and we'll see all the layers that we want to import. I'm going to import all of those except for layer not. And I'm going to bring in any lines, any polylines. If I had points without columns, I would bring those points in as columns. So if you've done a plan, then that would allow you to create those as columns automatically. And we're going to extract that into the workshop directory, and it's going to be called MF layer $5. I'm going to call it Fred, and extract. Off it goes, and it did some additional work, and I can now just load automatically MasterFrame. And here we come straight into MasterFrame. I noticed somebody was just asking there, what is the current version of MasterFrame? About MasterSeries, I am using 2007-11 from the 27th of July. That was, I believe, yesterday. So that is the most up-to-date version. So here's my frame. And if I turn on a little trick called nodes and make these node bullets a bit bigger using DirectX, you will see, for example, as I was saying, we don't have a node here because these two members crossed, and that's a bug. We also have two nodes here because we have a gap. So what I can do is if I take these back down to small wireframes, we'll see there's a separation there. So those are the typical sort of bugs that you can end up with in a frame. Easy way to identify some of those is probably to put it into plan and turn on your member numbers. And you can see here we're getting a double member because it's the 15 and 16, and over here we're just getting a single member, and likewise we're getting a single member. So these two members labels lying over the top of each other is sort of telling me that there's something strange going around here, because they shouldn't really be lying over the top of each other. So back out, turn off my members. So I can go through and fix those very quickly. Edit, geometry, define new members, and in fact just choose split two members at an intersection. And I choose that member, and keep the two members as a super member. Well, you'd probably only want to keep one of them, so I'd say yes and then delete the one you don't like. It's probably quicker. Sorry, my mouse is a bit on the sensitive side today for some reason. And proceed. So that's put that node in there, as you would expect there would be node points. Now, this one over here is a lot harder to find, and we can use some tools to find that for you. And one of the best tools is the model cleanup. Is show and merge coincident nodes, and it's going to show us where we have some little problems. And what I can do is say, show me any nodes that are within, for example, 1,000 millimeters. And now we should see red dots here, and here, because obviously those are quite close together. But it's these ones we're really interested in. So if I take that down to 100 millimeters, we can see we've nothing that's closer than 100 mil. And in this case, I think we pulled it apart quite far so that we could see it. And now at 200 mil, it is showing these two up. Naturally, they wouldn't be normally that far apart, but we just kept them far apart so that you could see them. But you're seeing the tool that is used to identify those. And then what you just say is, right, merge. Node to merge is that one, to merge it with this one, and say proceed. And I did that backwards. So I just undo that using my undo, and just do that again gently. Merge node, that one. It actually automatically put in the second node for me, and I say proceed, and this time it does it. So I didn't have to actually click on the second node, it actually found it automatically, and by me clicking a second time it was reversing that. So there's some of the little problems that you have when you bring in Dxf files. You also have problems, maybe there's an inaccuracy in the drawing, and I actually find it very useful to do things like come along and use the change XYZ, and I come along and I say let's look at all these, and it's telling us that they're all within the same. So changing the Y height, I just reset that and re-input them. There's no differentiation, so I didn't get a variance in the two values, so there's nothing over here. So they're all the same value, which is quite clever. Now, I now want to look at member editing, some little tricks and tools in the member editing. So I'm just going to move along and open a typical frame. And if I look at this little frame in plan, I don't really need to see my grid lines. I know roughly where it is. I just turn that off, I'll see that I have all these members. Now, if I come along and insert a member along here, what I can do is I can go Geometry, define new member. So my mouse is really sensitive, and define a new member. And I can come along and I can say right from the center of this, and I can go, as you can see, with the green highlight perpendicular to the new member, or orthogonal, which is also in this case perpendicular to the original member, or at the third and midpoints. Now, if I was doing a snap to something like this point or quite close, I might want to turn off these distances if the member is short, because by turning off the distances I only get the midpoints. So what I can do here is I can go %50, take my midpoint, and then I only have those values. So I'm going to do this horizontally. But before I do that, if you notice, there's a switch here that we introduced not so long ago called Keep as Supermember. So I'm going to say click on that, which means that it will make this member here into a supermember. So let's have a quick look at our supermembers so we can understand those. And we'll see that I have created 4 supermembers, and it's put in 2 new supermembers for that location. Now, this is great because the supermembers obviously are the real members. If I want to now take and modify this just by the change, now it used to be that we would suggest that sometimes that you come along and edit a coordinate. So if I wanted to take this node, I could shift it up in the z-axis by say 2 meters by changing the z-axis value from 7 to 9. But that is very limiting. In this case, it would be more beneficial to us to shift the node. And what will happen is when we come to shift, I take the same node and I say I want to shift it in the z-axis by say 2 meters. Now, watch what happens all of these members when I do that. They don't change in location, they just stay where they are. But we now got a bend in this member, which means that it's no longer a supermember, and likewise over here. We now have with the 2011 this function to keep supermembers straight, and now it's pulled it so that that member which was at that angle continues at that angle. And I say proceed. Now, another very useful function is if I go back to my shift, and I want to shift this node, so reset, but this time I want to shift that node not in the X or not in the Y or Z, but along this rotate length. So if I say, what's my X and what's my Z? Well, let's forget about that. Let's just say I want to shift that node along this member. So that gives me my orientation by 2 meters. And it gives me automatically my X and my Z. And I say show new frame, and it obviously pulls that back up. And again we have this keep supermember straight. And obviously it's not going to come to horizontal because it's 2 meters along the member rather than 2 meters in the Z. So if I pull that back down to 1 meter, and we'll see it's drag that along that length. And naturally if I want to shorten it, it would be by minus a meter along that length. So that again is a very powerful and Obviously by doing it several times I keep pulling it back by that shift. While we're here, let's have some fun. What I now want to look at is another little defining one, and that is to define a new member in a floor panel. So if I was to take this and select this floor panel, interesting, I can now say I want to be parallel with this member and I want to be 2 meters away, and it draws me a member 2 meters parallel to that. So that is very, very useful, because I would have had to try and work out otherwise these two offset distances, which would be very, very, very difficult to work out. Whereas using the floor panel splitter, as I would call it, we can say which member parallel, and we can say give me 3 of them. So bang, 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 they're all at 3 meters. And it's a great little routine. And again, we would say keep as super member, so that this member here becomes a super member. This one was already a super member, so it's only going to be, it's already happy. And I would say proceed. So that's another very, very useful tool that is quite powerful. Now, in the editor, what we will find, and this brings me on to another topic, is that we will have viewing member groups set up already. So we'll have set up a group 0, because that was a layer 0 layer. Those members are all in a layer called 203. These members are all in a layer called 20330. These ones in a 52, and those ones in a 25. So it's taken the layer names and used them as member groups, which again can save you time and effort. Let me see, where do I want to go from here? Yes, before I go on to member groups in detail and nodal groups, there was one little question that came in that was submitted that was asking about members and deleting and members by mistake. If I go to define a new member, and let's just put this on plan and just use the roller to zoom in. With the roller, if you roll, it zooms in centered on the node that you're over. So if I was over here and did a roller, it would stay centered on that, which is very useful, but I'm going to go into this area here. So if I was to put a member from there to there, it will take out the existing member. So if you draw exactly over where something was previously, it will remove it. Naturally, by putting it back in again, manually I may have lost some data that was already on it, be it section properties, be it loading, be it whatever. So rather than do that, it would be more prudent to do the undos to get you back to where you were. So that's your member editing. And as I said earlier, these little snaps, as you can see, are the percentages, and I do find it useful frequently to turn them off. So if I was just doing bracing, I can just go from node to node without having to worry about accidentally snapping on a short member. So if I was doing this member, I could put a brace across here. If I kept those in and I want to put a brace across here, I could be, 6, 7 different points there, not exactly on the node. So place safe, put it in, and in it comes. So taking those out, naturally you all know that we can also put on member distances too, so 2 meters and 4 meters from either end of that member is available. So now I want to look at member groups and nodal groups. Member groups and nodal groups are very, very, very useful, and what I'm going to do is I'm going to open an existing frame. I will save this time, even though it's a bit of a mess, and I'm going to look at a different frame. I want to take one that's already analyzed. Yeah, this frame usually gets analyzed, so it has been analyzed. Now, viewing groups, member groups. Let's look at member groups. In this case, we have these four members in a group called Portal. We've put these four members, and I just turn off the member numbers, into a group called Bracing. And I've put these into a group called Beams. Now bear in mind that those two members are in both Beams and Portal. So we can have a member in more than one member group. Because what these member groups are, they're filter tools. So if I add another, take my new group, call it Tommy, and go to apply mode, I can take that member, that member, that member, that member, that member, and that member. And they're all in a group called Tommy. So that's my member viewing groups, and that is and will be useful. If I want to now look at nodal groups, I have a group called outside, which is all these nodes on the outside, and I have another group called super member, which is for this because it was a super member, and I'm going to create a third group, and I'm going to call it Eaves. So what can we do with these member groups? Well, with member groups, if we were defining section properties, we could, for example, look at the portal individually by saying let's only see the portal. So if we go right mouse click viewing options, I can now go and say draw only member viewing groups called portal, and we have to turn it on. So now I'm only seeing that in a large frame. And then I can, at this point in time, leave that on the screen, go back to my editing, take my section, change it to a 533, and then just copy that onto all of those. So I've now applied it, removing all my hunching. It doesn't really matter today. So I can now update all those members in one go quite simply. When we're in our design process, we can also use this filtering. So we will be looking at this in detail in a moment. We're getting an idea of how it works just as we work. I can also, if I wanted to do something, say having analyzed it, hopefully it will analyze, plane frame, and I have a load outside a node. That's brilliant. Which actually brings me to another topic. Where was that error? And now I have to make a confession here. We had this for years, this messages file, and up until this current 27th of July version, it had suddenly disappeared. So if you go to about messages with the current version, you will get a message log of all messages since you started. So loads outside member 4. So let's have a look at member 4. Just put that over. Edit. And close that down. And just go to properties, loads, member loading. That's member 1, 2, 3. This looks like member 4. And we do appear to have some loads at 5 meters, when in fact the member on this side It should be a super member. I'm not sure if it is a super member, and that would probably be the problem. If I go to super member, define super member, yeah, it's not a super member, so that it should be a super member. Otherwise those loads were too far away. So let's add in a super member manually, and we add this and this. Now let's try analyzing plane frame. I think this has another problem. I think it's got lateral loading, which I need to solve. So just analyze again as (16 theta z). Okay, so it's in here. I have a problem. So geometry, what's my end conditions? Yeah, I'm getting this to be unstable in here because it doesn't see. When we put a release at both ends of a member that is fully released, then it will actually put a torsional restraint on one end to stabilize the member. But because this sees this as two separate members, it doesn't do that in this case. So I would actually need to go into two of these and take out the torsional release. So that is restraints, end release, member end releases, and leaving the torsion in, I would just come along and put those two back in, and hopefully that will get me my... No. I'm still getting a problem. Edit. Member 10 was the member that want me to auto split. So let's see geometry, super members, metal cleanup, auto split members. It's got an instability here because I think that was just one member. Yes, it is. So this column was sitting up here, probably pinned and just flopping about, and I will just go auto split, proceed. So Tommy, you should always listen to what it says on the error reports. Now for a third time, let us analyze. No. And I now have all my supports I need to set. So edit, restraints, static supports. So I don't have enough supports, and I'm just going to come along and delete all of these, and then just come along and make them fixed. And in my case that will hopefully get me one more step down, and we're still got a problem. So edit, properties, restraints, static. They are UT. Oh, I think it's got pins, so I need to actually put some vertical restraints up the side. So just to make this work, I'm going to just be a bit bold and put rigid restraints up there. No, it still doesn't like it. Node 16 theta z, right, let's find where node 16 is. 15. So I can't see, there's 16. So what's the problem? It's still got an instability here. So edit. Tell you what I'm going to do. Just because I want to get rid of this and get on with it, I'm actually going to be bad and just delete those bracing members and put them in as standard members. So possibly the easiest way is to go and merge, that's it, merge two members. I'm going to merge that with that and say proceed. I'm going to merge that with that and say proceed. So the node now drops out, and analyze. There we go. Happy days. Wasn't the order I had intended to do this debugging in, but it still is being covered. So we're back into seeing what our member and nodal groups can do. If I now look at my output and I want to view tabular output, sorry, member forces, I can use my filters. And again, people overlook these filters. So I can say member forces, I'm going to look at all the maximum values, and I want to see them for that section size, so only those three members have that. So I can do that filtering if I want to. Not necessarily the most useful. I can also filter to say only give me horizontal. Excuse me one second. And that again works well. But more importantly and more selectively is I can say show me only the portal, so I can get my portal. I could say show me only everything but the portal, so not the portal. So it takes out the portal members and gives me all my results. So we can be very selective in our viewing of our results for printing purposes. Likewise, if I was dealing with my nodal deflections, for example, and I was dealing with loading case 2, the only serviceability case, I could say show me all the outside nodes, so it gives me only those external nodes. Or give me all the eaves nodes, and it gives me those 4 nodes, and I can see my X, Y, and Z displacements. So it's very, very useful, this, for filtering. Now, again, coming along, output. This time we can use the same thing in the graphical. And when we're looking at, say, bending moment diagrams, whoa, let's scale this down. We can put on our values. That's a bit severe. But what I could do is I could then go to my viewing tools and I could say for labeling, give me only the values in the portal, and there we go. We only now have the physical values written on the portal members. So you could say come back to your graphics and say I want deflection with geometry, and it's giving us the in-span deflections in those. I could say show me X, Y, and Z's, or X and Z, or in this case just X displacements. And again, I could go to my viewing and I could say only to display the nodal on the outside, and it gives me only, obviously, plus the in-span one since I haven't turned those off. So go back to my editing and no in-span, so just a nodal on those, and again print that out. So you have this member grouping and nodal grouping being very selectively useful for you. Okay, we've covered error reporting a bit, but what I want to do is take a file that I know has a multitude of errors, and this is a very, very important area for you. So coming back into my workshop files, frame with bugs, very appropriately named. If I want to analyze this, it gives me all these errors, and remember, I'm just going to close that. I can look at the report by just going and looking at them. But before I do that, let's look at this reanalyze with 1% partial fixity. The answer is, first time, yes, let's do that. Now, remember that you should never use that for going on to do design. This is a diagnostic tool only. So having analyzed with the 1% fixity, let's look at our graphics. Bending moments, that's not going to tell you much. What's going to tell you is deflection with geometry. Oh my goodness, something's drastically happened. So the first thing we do is we go to a 1:1 scale, and we probably want to put this into like a front view, and we can see that we're getting movement around here. And what we're seeing is obviously we've got a column that's got no support here and here. So if we go back in and just look at the back of this, we can see, oh gosh, that column's got no support because it's just dropping right down. And I think there's another one in here somewhere. Yes, the inner corner. And this one's got no support. So very quickly, coming out, fixing those errors. So edit, restraints, static. And I can see automatically, yes, I should have had a in there. This is different. This does have a fixity, but it has no torsional restraint, and that's for a different reason. So now we come along and we can reanalyze. We're still getting instability, and we say yes. So we're going to step that one stage further. Again, into graphical and into deflections at 1:1 scale. So the next trick is to put it into side view, and we can see there's movement here, because we should not see much movement between the real structure and the original structure and its deflected structure. We can see a massive movement here, and the other way to look at it is over here. So I'm going to use my windowing to slice this up so I can see where I'm getting my problems, go back and look at it and say it's in between here, and slice again. And now I can see that I have got a kink at whichever level. In fact, we probably could have come along and said, well, actually it's only at that level. It's in that second floor. And it's to do with pins, to be honest. I know what the problem is. But looking at it, I know that there's a fixity problem there. It's hanging like a container. So we can walk through and do some more fixing of these sorts of bugs. Now, I did cover these a couple of weeks ago, or a month ago, in the MasterFrame tutorial. So I don't want to move forward and doing all these bug fixes. It was just to get you an idea of looking at that report and looking at the graphics to see why it's and what it's doing. Now, a little trick: if you haven't or are unable to update to the latest version, if I go analyze again, what you can do is you can go to copy, open up something like Notepad, bring Notepad onto I'm working with two screens, and then to paste, and you've got a record. But for those of us who have the latest version, you won't have to do that. So it's telling you, and it's also suggesting some solutions. So those are some of your diagnostic tools for fixing these frames that won't analyze. In the end, you must always analyze without using this 1% fixity. At that point, continue on. So, yes, I just noticed a little message. Yes, too many releases, and that's exactly what that problem was. It was going as a catenary. So now what I want to look at, we've looked at error reporting, we've looked at shifting along a member. I want to now look at sway stability and shear cores. And I'll do the shear cores first because this is primarily a MasterFrame Workshop, but it does sort of move into the Model Manager and sometimes into the Wind as well, where we can. So let's go and get my other frame. I've created these frames just to save myself time. Okay, and this is my little frame. And in this case, you'll notice that by default all the members are drawing short, which is a useful tool sometimes. So you can see the super members are drawn short of the nodes, the intermediate nodes are connected to each other, so we can see where our primary and secondary members lie. And that's available through these buttons here, which are only really available again if you've got MasterCAD. So I'm just going to turn those off because it's a wee bit disconcerting at times. So let's look at our frame and plan. What is our plan, if you pardon the pun, is to create a shear core around this area and over here. And we'll do this one first. So what I'm going to do is I'm going to Window, just a slightly larger area than we need, put it back into 3D, and it's this back face that I'm interested in. So Edit, Model Manager, because this is a Model Manager tool, and define shear wall. And we need to do some housekeeping afterwards. So put it back into 3D. Thickness, I'm going to go for 250. First node and second node, the two horizontal extremities of the wall. That's better. And it knows the lifts. And in this case, I'm going to do this two ways. I'm going to say show new frame, and it creates a single column down the middle of the wall of the right width and length, so 6'9" meters by 250 wide. But we lose the columns at either end because they normally are not needed. Now in this case it is needed because we will need this as a dummy member for forming our wind panels. So in this case I would say keep, and I'll say proceed. So it's put these in as dummy, left these in as dummy members in this case to make your life a lot easier. You could, if you wanted to, get rid of those three as a dummy member. So that's the easy one. What's it look like? 3D looks like this. It is in essence a single, as I say, column of the width and thickness that you expect, but we also then have these horizontal members at each level, which allow us to rigidly take our load from this point back to the center of the shear core. So these members here, these what we call rigid link members, provide a very useful tool and give us a correct analytical model. So a discrete shear wall, dead easy. Let's look at our second problem. Our second problem is in around here. So in this case I'm going to zoom. Whoops. It's my mouse again has been very sensitive, as I was saying. I can only apologize, but I will keep going. Right. So here we go. And what I've done, and we'll just go back to wireframe, is I have created a column at each end of each surface. And that is how I would always recommend you do shear cores. You create the columns at all the distinct points. So we're going to have a U-shaped or a double U with an opening and a return at each face. So let's start. Thickness 250 sounds good. First node, second node, proceed. And again we've got this keep dummy columns. We can just turn that off, and I might just do a quick undo. There we go. And now do a proceed. Oops, undo again. I'll just do that all from scratch, that node to that node, and proceed. And where's my frame gone? What's happened? Not certain what's happened. But let's keep going and see what happens. From here to here and proceed. There's the members coming in. From here all the way across to here and proceed. And from here to here and proceed. And then from here to here and proceed. From here to here and proceed. Now if I turn on my 3D, it is looking sort of correct. For some reason I haven't got these two returns in, and I'm not certain why. But I also now need to put I'll look at those in a minute, but I do need to put this member in here, which causes me a problem, because as soon as I go from here to here and proceed, I lose this back one. So the order can be important, but it's not a problem. I can just go and put them back in again, put it back in again and say proceed, and it should come back in again. Now why it's not doing that, I'm not certain. I would need to look at that and see why, and possibly do another wee video on that for you. It's obviously got annoyed at something and is not putting those back in again. What I'm going to do is I'm going to come out, say yes, and go back in again and try it again. See what we get. And now if I go edit, and yes, it seemed to have put that as a big long member there. Why, I don't know. So shear core, let's get this finished. And I'm going to go from here to here. Proceed. Let's see what I've got. Yes, I do have the member where I wanted it now, and I should be able to get that returned, but I lost those ones. I will look at that again for you and come back on that. Now, if I take another frame, it is asking me to do an auto split, and I would say proceed on that automatically. So it's now repaired that. If I take a different frame, for example, the frame we did earlier, so if I just go down to recent files and take this steel frame, somebody asked us about sway stability. Sway stability is done in like 2-3 stages, and if I come into loading, special loading, special loads, I can go to horizontal notional loads. So at the minute we're actually working to the Euro code, and I probably should go back to my loading combinations and tell it that I want to work, in my case at the moment, so we don't confuse everybody, to the British standards. And now go to notional horizontal loads. What I do is I turn on that I want to do notional horizontal loads. I turn on that I want to do 0.5%, and I want to do a find and add. And all I need to do is tell it which loading directions to do, so 0 and 180. And I say create all. And it's now created for me a dead plus live plus notional at 0%, so it's going from left to right. It's also created the opposite, dead plus live plus notional, with the reverse 180, and likewise sway stability on its own at going left to right and right to left. So it's created all those loading cases. Now it also, sorry, wrong drop list, in the first loading case will have created that it's going to do a find and an add. So it's done all the cases. I can analyze this plane frame. Whoa, non-linear. Must be those tension only members. So if I go and edit geometry and delete that that bracing is all tension. And if I make it tension and compression, so loading, member loading, take this and get rid of this. If I say now global, find me all the ones that are tension only. And what are these? They're similar. So if I just get rid of those and these, rather than making the frame more rigid, I'm just trying to speed up my process here. And still a convergence. So I don't really have a file that I want to work with. So let's open a different file. Okay. That should do. And should I analyze that? Ah, we're still getting bugs in this one. But it's happy. It's happy. So this is really to do with steel design, this part, rather than the master frame. But just to recap, what would happen once you've done your sway stability is that you wouldn't actually act upon it and do P delta or anything like that until after you've done your design. So you would come along and you would do your design and you would look at your elastic critical load factor. So there's no P delta and it's large P delta. So is P delta on? No. So there's no P delta applied. And in each loading case we're looking at a lambda crit of 4.4. So below 10, above 4, we could use a K amp. Loading case 8, it's above 10, we don't need to worry about it. So only in this one loading case do we have a problem, loading case 6, dead plus live ultimate. So we would need to go back and use this K amp, but we don't use K amp because we have a P delta analysis method instead. Now, before I would jump the gun and go and do all that and apply a P delta, I should design my frame, because there's absolutely no point looking at these values and how sensitive it is until you've got section sizes for all these members. Only once you've sized all those members would you ever consider looking at this information and deciding now for the real section sizes, is the frame now sway sensitive? No. Oh good, let's do nothing else. Or yes, it is sway sensitive, it's above 4, below 10. Well, I'm not going to do sway amp, I'm just going to go back in and do a full P delta. So P delta, so assuming I've designed, I would come in to edit and go to my P delta analysis, and P delta analysis is turn that on. Sorry, Martin. I was speaking to my colleague here a minute. I just want to put you on mute. Sorry about that, ladies and gentlemen. Right, I was having a problem actually applying the P-Delta. There was a switch that wasn't allowing me to turn it on, but I managed to activate it by turning it on in using a different way. So if I come back here, we still have our sway stability, but our analysis options, we will be using P-Delta. I need to get that turned on. There it is, it's on now. And there are three methods. There's the Newton-Raphson or the geometric stiffness matrix method. And for a multi-story building like this, we would recommend the geometric stiffness matrix method. And that will analyze and give you all those. Now, if it was a portal frame or portalized type frame with sloping members, we would use the Newton-Raphson. What you must remember with that is that we are using large P-delta, so we're just concentrating on the nodes. If you wanted to know the additional deflections at mid-span of columns, etc., you would be advised to apply a few additional nodes along the members to actually obtain those values. But certainly everything that's analysed will be given out to you as deflections. We also have the ability nowadays to do plastic analysis on the frames, and I believe Martin talked on that in one of his latest webinars. We'll probably put that into the notes as to where that's about. So we're now at 10 past 2. I said I was going to try and cover everything I could in that time, and I would continue until there's nobody here. I see there's still about half of you still here. What I want to talk about now, in this overtime, so to speak, is mixed construction. We're moving into a model manager feature of MasterFrame. So if I come along and open up another file and go to mixed construction, here we go. This is a very simple frame, not very realistic, but it gives us our point. I have a 4-story building, and I have a little sloping roof out the front. I haven't bothered putting columns down here. It's not that structurally sound at the minute. It's going to deflect a lot. But in essence, what we have is composite for all this, but this bit out the front is all non-composite. And that causes us, at first glance, a little problem, because if you think about it, in our editor, when we go into Model Manager, Area Loading Defaults, we get the set whether it's composite or not on a floor-by-floor basis. And to me, the basic rule is that you apply it. If there's any composite on a floor, you say that yes, that floor is composite, and then you make the members that are not composite uncomposite. So we've told it that all the floors are composite with a 150 deck. Now we look at the second phase, and we come down to our member groups, and we now tell it which members are not composite, so steel and composite design groups. Sorry, apologize. Mixed construction, that's the one I want. So I have told these 6, 7 members are non-composite. They've been changed to be non-composite. And that's all I've done at this moment in time. The other thing I have done is I created it as a separate panel. So here we go. And in the panels I have overridden the live load and the dead load by their new values, 0.25 and 0.75. So, and I've put nothing in here for the thickness. So what will happen? Very good question. If I am to look at my overall area loading with my key plan, so I get rid of this, I don't need that for the time being. So at the minute we're saying partitions of 1 on both surfaces. Even though this is steel, it's still thinking the partitions exist. And if I call up my viewing tools, that's a right mouse click by the way, in case you haven't learnt that yet, and I now look at my gravity loading legend, that's the one I want, and into composite. So slab thickness is assumed to be 150 because it wasn't told otherwise. Slab weight is heavier in the steel area because it's a solid rather than a profile slab. I have my construction load of 0.5, I have my partitions, I have my mesh, I have my density, well that's not going to change, and I have solid and quick span. So we need to do something else to get rid of those additional loads on that little entrance canopy, whatever you want to call it. And what we need to do is we need to go back to my area panel, choose the panel I'm interested in, this one, and I need to give it a thickness. If I put 0 in, it's going to have no data and it will actually default back to being the normal thickness. So instead of putting 0, I put 1 mil in. And what that does is pretty fantastic. It gives me exactly what I want, because now my construction loads is 0. It sees the 1 millimeters as being totally stupid for anything, and therefore it takes 1 millimeters as being 0. So Lord help you if you've got a 1 mil thick slab. Partitions are ignored, they're 0. Surfaces are 0. The mesh is 0. Well, the density, yep, that's 0, and it's solid. If we look at the thickness of the slab, it says 1 millimeters. That's okay. But the self-weight is 0. Now you would have expected the 2.8 if this was going from 150. You would have expected a value of about 5 or 10 in here. You don't have that. It sees 1 millimeters as being nothing. So that is how you would do it. You actually put in 1 millimeter thickness for your slab as well. So that's covered everything that I wanted to cover today. Sorry for that slight little hiccup on the shear core. I will probably get one of my colleagues to actually redo that and re-record that wee bit. We'll just stick it on to the end, doing it properly. I'm not certain why the file was getting a bit annoyed with me. Any questions that are left over? What are super members? Does that need answered, Martin? You've answered that? That's great. So, Harry, it has been answered for you. No other questions, no updates, that's okay. That's great, latest version. So I don't believe there's any other questions. There was one late question that came in today on curved members. And this is fun. I like this one. It's going to be totally stupid, but I don't care. Let's do some curved members. We don't, as a rule, allow you to curve members. Now, I'm just going to do a couple of things here. First of all, I'm going to go to super members, and I'm going to remove them all, because that would annoy me, because curved members can't be super members and vice versa. We don't actually do curved members. So what I'm going to do is I'm going to go to geometry, and I'm going to take one of my members and how do I split a member? Split a member. I wasn't seeing it properly. There it is. Split a member. So let's take this back member so we can see it nice and neat. And we're going to split it 8 times. And we're not going to keep it as a super member. And I say proceed. So hopefully we should now... No, it didn't split it. Why did it not split it? Oh, ratio of 8, so number of segments is 8. Silly Tommy. This time when I say proceed, I get 8 little dots. Lovely. So now, just shift this into the center of the screen. If I want to now curve this member or this member, we actually create facets. Straight facets. We only handle straight members. So we use the position on circle. No, I don't want to use the position on circle, because wait till you see what it looks like. It's going to ask you where its center is and what its radius of starting angle and ending angle and increment. That's a lot of work, and most of the time we actually understand it in a different form. We understand it using the arch. So reset everything. Let's take everything here, obviously not that node there, and let's have a look. Yep, that's only those nodes. Camber. Let's give us a camber. I'm going to give myself a camber so I can see what's happening of 1 meter. And let's see what it looks like. And what's happened is that it's done a vertical rotation of our member, because that's what a camber usually is. Now, where's my nodes? So what's happened, if we look at the length of each of these, is that they're all different lengths because they've all jumped vertically upwards. Instead of doing that, I can make them all equal, and watch what happens to the nodes. They just move slightly so that the lengths are all now equal. So that's your vertical camber. If you wanted a horizontal camber, what you do is you rotate the frame through 90 degrees, and then it becomes a horizontal curve. Naturally, you can go for a value in between 0 and 90, or you could go for minus 90 for a cut back in, or you could go for minus 40, which means that it's sitting at a most precarious angle. It's hard to see that. If I rotate that, you'll see that it's sitting up at a most obscure angle. Handy for doing these very fancy bridges, but not very handy in reality. So I'm just going to go back to being 90 degrees out. And once you've had, whoops, where are we? There we are. We just say proceed, and it's done. So that's how you curve your members. You create facets, and you don't have to get that number, massive number of facets to get a realistic curve from an analytical point of view. In some cases, 2, 3, 4 segments is more than enough. You obviously want one right out at the tip so that you get the lever arms you require. So I would suggest you're talking about probably 4-5 facets. Okay, this has actually brought up some interesting questions. And can you kink a super member? No, there is a slight tolerance allowed of 1 or 2 millimeters, but that's all. A super member must be straight. And somebody else was asked, how do I design haunched eye and box sections? Well, the haunched eye and box sections, we cannot design them. You can create your own haunch section as a plate girder. You can, if I went into properties, sections, this is actually a very good example of something. If I went in, say, to that member and I just zoomed right up to it so we see it in 3D, and there's my member. If I go into steel, I have the ability to do my UBs, UCs, RSJs. I also have several sort of like user defines. I have flats, so I can choose a depth by thickness. I have round and square bars. Well, they're pretty straightforward. But as well as that, I have this built-up section. So I now can define the dimensions of my section. So I can create any section I want using that. And I obviously can also, I cannot haunch it because it's not a uniform it's not a standard member. If you wanted to then haunch that, you would have to go and create it in the open library to get it to design it as a steel member. So that's the only way to design a tapered eye section, would be to create it in the open library of steel sections, bring it in here, put its tapering on then, because we cannot taper these built-up sections. The box section, which can be tapered, we can't do anything with that at all. There's no way of designing that at all. If it was uniform, obviously you could create it in your open library of rectangular hollow sections and then design it. But we're not talking box girders, and we're not talking about local wall stability and stuff like that of plate girders. Now, finally, and I think this would probably be the last question, Johnny Moffat has asked the effective length for design of a curved member. Well, hopefully, Johnny, most of your curved members would be fully restrained, and therefore we don't have an effective length to worry about. Other than that, I don't have any guidance on what you use, and I can't really advise you. And that's one of the reasons why I suggest you try and create your curve using as few members as possible, because I don't see you having a curved roof or anything like that that's not got some intermediate stays and restraints. So I would use those to create my facets. Other than that, there's really no guidance. The questions are coming in now quite fast, so I'm going to keep going. While you're still here, and half of you still are, I will keep talking until I run out of tea or coffee. Okay. Christoph has just asked, how can I see internal forces in the exact point, i.e. where the bending moment is 0? That's a good question, and I'm going to come out of this and hopefully find something that will analyze. Let me see if I go to concrete frames. I know this one hopefully should analyze. Yes, it has analyzed. Output, graphical. Bending moments. There we go. So where's that point? Well, that point will move depending on loading cases for a starter. So if I want to envelope, we actually get several different points for that. If I now go and zoom in, you'll see that that point moves about. But for any particular loading case, we could interrogate it. You could obviously try and scale it. You can also tell it that you want to put your intervals at 200, so you can go 1, so that's 2, 4, 6, 8, 10. So it's roughly a meter out. I say roughly. That's as good as you're going to get using this method. You also can go to internal forces. So you can say, for this member, I can see that my internal force is between 1.8 meters and 2.1. That wasn't a bad guess. I said counting up 2 meters. So we could now come along, and obviously that's actually measured from that end because it's a 3 meter length. We could, there's 3 meter length. I could now tell it that I want to look at the distance between 1.9, so 1.9 and 2, and that's going to get you right down to the pretty close to the money that you're seeing. That is very, very close. Other than that, I just asked my colleague Martin, is there a more accurate way of determining that point of contraflexure? There isn't at this moment in time. We do tell you where the point of maximum moment is on a member, which is normally not necessarily at the midspan. In our bending moment diagrams, we give you the maximum moment and its point, its distance. The point of contraflexure, that's as accurate as you're going to get it. You could put in distinct points and try and move them about to hit that value. It is going to move for loading case to loading case, and is really only required when we're doing our design, and our design knows everything anyway. If we were talking about our steel design in designing our Appendix G out to the point of contraflexure, it's going to automatically know where that is for each loading case and do it. If we're talking about the concrete design, well, it knows what its envelope looks like anyway, and it designs to the envelope for curtailment. So all I can give you, Christoph, is a reasonably accurate approximation of where it is. I could go down to the nearest millimeter with a wee bit of time, fine-tuning this distance. I could turn around and say it's 0.99, and I can see that 0.99 is moved over too much, so that's 1.99. So we can see that it's coming in there. Well, I think that's pretty accurate enough. That's to the nearest millimeters, which would, in my mind, be pretty good. Personally, I just call it 2 meters. But that is, as I said, for that loading case. If I moved to my next loading case, we would see that we haven't covered the point of contraflexure at all. And it's moving about from case to case. So hopefully, gentlemen, that seems to be the last question I needed to cover. Everybody has asked their questions, and I would like to thank you all very, very much for attending today. You will get in a week or two a little email telling you that the video for this has been rendered and produced and that you can view it. So thank you very much. If you do have any more questions, don't hesitate to email them in. Just go straight to help@masterseries.co.uk. That will get it to the right person rather than myself or Martin, who may not be the expert in the field you're after. So thank you very much and goodbye. I will just now pause this and then turn off the session.